Okay, next up we're dealing with a binomial. Okay, so there is a couple ways to do this. So, typically if there's many ways to do something in math, they both represent doing the same thing, but one is derived off of the other just to speed things up. And so, let's use, it's always best to know so I call it the basis method, but what the long method is. That way, if you do mess up with these other methods that tend to be quicker and are short forms of this basis method, you can tell when you go wrong, or you can double check with your basis method. And so, what everything here is derived off of is going to be the binomial theorem. And that just states that x plus y all to a power is going to be equal to the sum from k is equal to 0 to whatever that power is of n choose k, x to the power of n minus k, y to the power of k. Now, if you're in high school, don't be afraid of seeing new math words, such as n choose k. Typically, it's just can be solved by just an equal sign and written in a form that you're more familiar with. So it's just shorthand notation for something else that isn't quite hard at all. Just because it's new doesn't mean that you should be afraid of it, basically. N choose k is n factorial over k factorial n minus k factorial is what that represents. N factorial is n by n minus 1 by n minus 2 up until you hit basically 1, because you don't want to multiply by 0. It's going to neutralize everything. So as an example, just so you can get more familiar with this, if I had 10 choose 2, that would be 10 factorial over 2 factorial multiplied by 10 minus 2 factorial. That's going to give me 10 factorial over 2 factorial multiplied by 8 factorial. And then you can plug this into a calculator if you'd like. You can also just simplify it. 10 factorial is 10 multiplied by 9 multiplied by 8 by 7 by 6 until you hit 1. That's the same thing as 8 factorial over 2 factorial, 8 factorial, cancel. This becomes 10 by 9 over 2 factorial. 2 factorial is 2 by 1, which is just 2. So that's 10 by 9 over 2. Divide out any common factors, and this becomes 5 by 9, just as an example. So, now let's figure out how to expand this out before we can go about finding what the sixth term is, because we need to figure out how to expand it so you know what each term is going to look like. So the first term, if I have 5y plus 3 to the power of 10, that is going to be the summation from k is equal to 0 to 10 of 10 choose k, x to the power of n minus k, y to the power of k. Sorry, this is supposed to be 10. And this is supposed to be alpha. And yeah. Okay, so I start summing at k is equal to 0. So my first one is going to be 10, choose 0, x to the power of 10 minus 0, which is 10. Sorry, I need to change these two. My x becomes 5y all to the power of 10 minus k, and my y becomes 3 to the power of k. So my first term is going to be 10, choose 0, 5y all to the power of 10 minus 0, so 10, 3 to the power of 0. My second term is going to be when k is equal to 1, so 10, k is equal to 1. So 10 choose 1, 5y all to the power of 10 minus 1, so 9, 3 to the power of 1. Plus, let's go ahead and write out everything. So when k is equal to 2, 5y to the power of 8, 3 squared. If you can't tell, the power for the 5y is decreasing by 1, for the 3 is increasing by 1, so you can just keep with that pattern instead of constantly saying 10 minus 2, 10 minus 3, so on and so forth. And so you're going to want to go until the power of 5y is 0 and the power of 3 is 10. Sorry, plus 10 choose 3, 5y to the power of 7, 3 to the power of 3, plus 10 choose 4, 5y to the power of 8, 3 to, sorry, decreasing by 1, power of 4, and this is going to be our last term. So 10 choose 10, 5y to the power of 0, 3 to the power of 10. Okay, so now that I have this very long expression, the question is asking for the sixth term. So the sixth term, since I start counting at 0, you need to keep mind of that, is going to be when k is equal to 5, not when k is equal to 6, because I start counting from 0, as I just said. So this is going to be my first term, my second term, my third term, fourth term, fifth term, sixth term. So my sixth term is going to be is going to be 10, choose 5, 5y, all to the power of 5, 3 to the power of 5. So let's go about finding what this 10 choose 5 is going to give us. 10 choose 5 is 10 factorial over 5 factorial. 10 minus 5 factorial. That's 10 factorial over 5 factorial by 5 factorial. You can just quickly put that into your calculator. You can simplify it by hand. This is going to give 10 by 9 by 8 by 7 by 6 by 5 factorial all over 5 factorial by 5 factorial. Let's cancel out one of those 5 factorials. This will become 10 by 9 by 8 by 7 by 6, and then let's also write out that 5 factorial, 5 by 4 by 3 by 2 by 1. The by 1 doesn't really matter. And then you can just divide out common factors. 5 goes into 10 twice, 4 goes into 8 twice, 3 goes into 6 twice, and 2 can cancel out one of those 2's. And this will leave me with 2 by 9 by 7 by 2, and that's going to give me 252. And so I'm just going to put that right here. This will be 252 by 5y to the power of 5 by 3 to the power of 5. Do not leave it in this form because you're not done. You need to simplify it completely for whoever is marking your paper, or you'll only get part marks. The point is to always make things as easy as they can be for the examiner, because that means you know everything you need to know. So we're going to apply some exponent rules, and that just states that x to the power of a, So x by y to the power of a is the same thing as x to the power of a by y to the power of a. And we're going to use that here. So we'll get 250. So you get 252 by 5 to the power of 5, y to the power of 5, 3 to the power of 5. So 252 into, we're going to use the reverse to bring this 5 to the power of 5 and 3 to the power of 5. So this will become 15 to the power of 5, y to the power of 5. And then you're just going to multiply things out on your calculator, and you'll get 191362500 y to the power of 5. And that's going to be it for this one. Now, the other way to do this question is going to be using Pascal's triangle, which is derived off of binomial theorem. But just ensure that you have understood the binomial theorem before you can use Pascal's theorem without understanding binomial theorem, because you typically taught it on the side in high school, but it's best to know where things come from. So Pascal's triangle, when I'm writing it, I start with a 1 on top, and then 1, 2, 1. From there I can build everything off of addition. So you always have 1s on the outside, so this become a 1. And then I'm going to add these 2. 1 plus 2 is 3, so I put a 3 here. 1 plus 2 is 3, so I put another 3 here, and then I have 1 on the outside. So your outsides will always be 1. Now I do the same thing, 1 on the outside, 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, 1. You just continue. And if you haven't noticed, there's symmetry in both of them, which tells you that they're on the same thing. Sorry, that wasn't clear enough. 1, 7, 21, 35, 35, 21, 7, 1, 1, 8. Space things out. So we get 1, 8, 28, 56, 70, 56, 28, 8, 1, 1, 9, 36, 84, 126, 126, 84, 36, 9, 1. We get 1, 10, 25, 120, 210, 252, 210, 120, 25, 10, 1. Sorry, this is supposed to be 45. So again, 1 plus 9, 10, 36 plus 9, 45, 36 plus 84, 120, 84 plus 126, 210, 126 plus 126, 252, so on and so forth. Now, the reason I did it all the way until 10, which you don't often see, is because I have the power of 10. And typically the number that you'll see to the power of is the number that you'll expect for your second number. Now, to use the Pascal's triangle, you need to understand how to read it. And so Pascal's triangle is when you have x plus y squared. And so for this first one, since I have 2, I'm going to use that. And so it'll become x squared plus 2xy plus y squared. And so 1, 2, 1. Now the pattern with the powers of what I have inside is similar to what I have in binomial theorem, where the x is decreasing by 1 and the y is increasing by 1. And so I had to go until 10 because my power here is to the power of 10. So I'm going to be using this. And this is going to be my first term, my second term. Sorry, this is going to be, again, start from 0. So this is when x is equal to 0, x is equal to 1, x is equal to 2, 4, 5, sorry. On this one, you can just count until you hit the 6th term. So I have 1, 2, 3, 4, 5, 6. So this is going to be the one that I'm using. And then I additionally need to note this is x to the power of 10, y to the power of 0, x9, y to the power of 1. So I need to know what it's going to look like by the time I'm on this 6th term. So I can just write it out. So I have x to the power of 5, y to the power of 5 is what my two coefficients are going to look like. So that means that if I had x plus y all to the power of 10, my 6th term would have been 252, x to the power of 5, y to the power of 5. But I have 5y plus 3, so I need to put in my x and my y. So this will become 5y plus 3 to the power of 10. My 6th term will be 252. 5y to the power of 5 multiplied by 3 to the power of 5. And then you're just going to do, if you'll notice, this is exactly the result we had up here. And so this will give you the same 191,362,500 y to the power of 5. That's what it's going to give you. Now, understanding how to use Pascal's triangle is a bit tricky, but once you do, it's easier to use quickly on the back of an envelope when you're trying to just do a calculation really, really quickly and don't want to go through writing out all of them for the binomial theorem. What Pascal's triangle does, if you haven't noticed here, is I got the 252 without doing n choose k. And so these numbers that you see written out here are the n choose k values. And so it's just a quick list of the n choose k. He probably noticed the pattern and made it a thing. And so I got the 252. It's just a pattern of my n choose k, and then you notice the pattern with the x and y's. And so that's going to be it for this question.